Welcome to the Deep Dive. Today we're jumping into Chapter 44 of Porth's Essentials of Pathophysiology. We're aiming for a really structured, concise tour of the female reproductive system.
Yeah, our goal isn't just to list parts. We want to get into the hormonal control, that neuroendocrine dance that runs everything function, the cycle, big changes like menopause, basically give you the core concepts you really need.
Absolutely. And it's a fantastic example of how structure dictates function. So let's start there maybe with the basic layout. And importantly, the book highlights some vulnerabilities right off the bat.
Right, so externally you've got the vulva that includes the mons, pubis, labia, clitoris, vestibule, but the key clinical point right away is just how close the urethral opening is to the anus.
And pathologically that closeness means.
Well, it just sets up a potential pathway for cross-contamination. It's why, an infection in one spot can easily cause symptoms or issues nearby. Things get linked.
Okay, moving inside then we hit the vagina, this fibromuscular tube connecting the vestibule up to the cervix. And you mentioned hormones. This area has a really neat hormone-dependent defense system.
It really does. The lining is stratified squamous epithelial cells, and their whole deal depends on estrogen. Estrogen makes them mature and, crucially, load up on glycogen.
Glycogen. So, like stored sugar. Why is that important for defense?
Because the normal vaginal bacteria, mostly lactobacilli, use it. They ferment that glycogen into lactic acid, and that process is what keeps the vaginal fluid normally acidic, which is hostile to a lot of pathogens. It's a chemical defense.
Ah, okay. And the clinical tie-in here is pretty direct, isn't it? Like after menopause?
Exactly. Estrogen plummets, so the cells can't make enough glycogen. The lining thins out, it gets dry, the pH goes up, and that protective acidity is lost.
Which leads straight to things like atrophic vaginitis, maybe
Oh.
dyspareunia to painful intercourse.
Precisely. It shows just how much that local environment relies on the bigger hormonal picture.
Okay, next stop, the uterus. Pear-shaped muscle tucked between the bladder and rectum. And understanding its function, especially monthly, means looking at its walls, right? The layers.
Yeah, 3 distinct layers. The outer one is the perimetrium, just a thin serratus layer. Then the big one, the myometrium, that's the thick muscle layer, provides all the power for contractions, like in labor.
But the real player in the menstrual cycle is the inner layer.
Yeah.
The endometrium.
That's the one. And it's got 2 parts itself. The deep basal layer that's always there, it regenerates things. And then the superficial layer, the functional bit that responds to hormones, builds up and gets shed during menstruation if there's no pregnancy. It's built for that cycle.
Got it. And just below the main part of the uterus, there's the cervix, the sort of neck. What about its secretions?
Endocervical secretions, they're like a gatekeeper, primarily protective, blocking infection, but they also change dramatically through the cycle, sometimes thin and watery, sometimes thick, basically controlling whether sperm can get through easily or not.
Dynamic gatekeeping. Okay.
Yep.
And then the fallopian tubes branching off the top with those finger-like fimbriae at the ends. The egg itself can't move, so how does it travel?
It's a team effort. Wave-like movements of tiny cilia lining the tubes, plus smooth muscle contractions in the tube wall. They work together to sweep the egg up and move it along. And that's important because fertilization usually happens in the middle or outer part of the tube.
Incredible engineering.
Yeah.
But none of this structure works without the hormones calling the shots. Let's talk about the ovaries.
Right, the ovaries, they have a dual role, kind of like the testes in males. They store the eggs, the ova, and they're the production factories for the main female sex hormones. Estrogen, progesterone, and androgens EPT. Structurally, you've got the inner medulla with blood vessels and the outer cortex, which is packed with all the follicles where eggs develop.
Okay, and this is where it gets really fascinating, like you said, the control system. This neuroendocrine feedback loop, it runs the whole show.
Yeah, think of it like a command structure. Top dog is the hypothalamus in the brain. It sends out gonadotropin-releasing hormone, GnRH. That's the first signal.
Okay, GnRH goes where?
Down to the anterior pituitary gland. The pituitary reads that GnRH signal and responds by releasing its own hormones, FSH, follicle-stimulating hormone, and LH, luteinizing hormone. These are the gonadotropins.
And FSH and LH then travel to the ovaries.
Exactly. They hit the ovaries and tell them to produce the EPT hormones. And then this is the feedback part. Those ovarian hormones signal back to the pituitary and hypothalamus to regulate their own production. It's a constant adjustment loop.
Figure 44 to 5 in the text really lays this out. But what's also super interesting, and the chapter stresses this, is how this whole finely tuned system is linked to the body's overall energy stores.
You mean the body fat connection?
Yeah.
Absolutely critical. The evidence is really solid. You need a certain minimum amount of body weight, specifically body fat, for menarche, the first period, to even happen, and then to keep cycles going regularly.
So why? Why tie reproduction, which seems so specific, to overall body fat?
Well, think about it from the body's perspective. Pregnancy and lactation are hugely energy expensive. If the body senses there isn't enough energy overall, like in anorexia nervosa or maybe extreme endurance athletes, it basically says, nope, can't afford this right now. It dials down the GnRH pulses from the hypothalamus, and the cycles stop. That's amenorrhea.
It's a resource allocation thing.
Yeah,
Fertility is a luxury the body can't afford if basic energy needs aren't met.
that's a good way to put it.
Okay, so we have the control system. Now let's see the hormones in action during a typical cycle. Estrogen first, there are a few types, but estradiol, E2, is the main one from the ovary, right?
Right, E2 is the most potent. Its effects are widespread, as Table 44.1 shows. It drives the development of reproductive organs, accelerates bone growth during puberty, and clinically it causes some sodium and water retention.
And that's why many women notice that bit of fluid retention, maybe some bloating or weight gain, just before their period starts.
That's likely the estrogen effect, yeah. Now, contrast that with progesterone. It really ramps up after ovulation, produced mainly by the corpus luteum. Its job is all about preparation
Preparation
for potential pregnancy. It stimulates glandular development in the breasts, getting them ready for possible lactation, and it drives changes in the endometrium, making it thick, vascular, and secretory, perfect for an embryo to implant.
Progesterone is also the one that causes that slight uptick in basal body temperature after ovulation, right? The thing people track for fertility awareness.
That's the one, a very reliable marker.
Okay, so walk us through the follicle development part. How does an egg get ready for ovulation each month? Figure 44 to 6 illustrates this.
It starts with FSH and LH from the pituitary, stimulating a group of primary follicles in the ovary to grow. As they develop, usually one follicle pulls ahead, becomes the dominant follicle. This one starts pumping out really high levels of estrogen.
And the high estrogen is the trigger, isn't it? It flips the feedback switch.
Exactly. Instead of suppressing the pituitary, that high estrogen level causes a sudden massive surge in LH. It's this LH surge that acts like the final command. It makes the mature follicle, called a Graafian follicle, about 20 millimeters wide, by then rupture and release the egg. That's ovulation.
Pop. Okay, egg released. What happens to the follicle left behind?
That enters the luteal stage. The collapsed follicle transforms into the corpus luteum, the yellow body. And as we said, this becomes a temporary progesterone factory.
And its fate depends on fertilization.
Right. If no pregnancy occurs, the corpus luteum starts to break down after about 10-14 days, becoming scar tissue called the corpus albicans. Progesterone levels plummet, and that withdrawal triggers menstruation. But if pregnancy does happen, the early embryo produces HCG, human chorionic gonadotropin.
The pregnancy test hormone.
That's it. And HCG basically rescues the corpus luteum, keeps it producing progesterone to support the early pregnancy until the placenta takes over.
Meanwhile, the uterine lining, the endometrium, has been going through its own phases.
Yep. First, the proliferative phase, driven by estrogen, where it grows and thickens. Then the secretory phase, after ovulation, driven by progesterone, where it gets really lush and glandular. And if no pregnancy, the menstrual phase, where the superficial layer breaks down and is shed.
And we shouldn't forget the cervix during all this. The mucus changes are pretty dramatic.
Oh, definitely. Around ovulation, estrogen makes the cervical mucus thin, clear, watery, and stretchy. They call that spin barkite. It's perfect for letting sperm swim through. But after ovulation, under progesterone, it becomes thick, scant, and viscous, basically forming a mucus plug. Huge difference in receptivity.
It's an incredibly synchronized dance every month. Okay, so eventually the system winds down, leading to menopause. How is that defined clinically?
Officially, it's the permanent cessation of menstrual cycles. Diagnostically, it's usually confirmed after a woman has had no periods for a full 12 months, or if blood tests show persistently high FSH levels, typically over 20 MIU/mL. And the functional changes are significant because that estrogen support is largely gone. We see urogenital atrophy, thinning, dryness, increased vaginal pH, which ups the risk for UTIs.
But for many women, the most disruptive symptoms seem to be the vasomotor ones, the hot flashes, maybe palpitations. They sound really tough.
They can be incredibly disruptive. They often mess with sleep, cause anxiety, really impact quality of life. And what's kind of frustrating scientifically is that while we know it's tied to the drop in estrogen affecting the brain's thermoregulatory center, the precise mechanism that triggers an individual hot flash, still not fully understood.
Wow. And looking bigger picture, long-term health risks also change after menopause, right?
Yes, significantly. Without estrogen's protective effects, there's an increased risk of osteoporosis bone breakdown starts to outpace bone building. And the risk of cardiovascular disease also goes up considerably for women after menopause.
Which brings us right into the hormone therapy, or HT, discussion.
Mhm.
This has been, well, hugely controversial over the past couple of decades.
Massively controversial. For a long time, based on earlier observational studies, HT was pretty routinely prescribed, often long-term, with the idea it could prevent things like heart disease.
But then the Women's Health Initiative, the WHI, dropped bombshells.
Total game changer. The WHI involved large randomized controlled trials,
Yeah.
and the key arms, one testing combined estrogen plus progestin, the other estrogen alone, were actually stopped early.
Why were they stopped?
Because they found that in the specific group studied women whose average age was almost 64. So many years past menopause onset the risks, particularly increased rates of breast cancer with combined therapy, and stroke and blood clots with both therapies, actually outweighed the potential benefits for chronic disease prevention.
That must have sent shockwaves through medicine.
Oh, it absolutely did. It led to a major reevaluation and gave rise to this concept of the critical window.
Explain that, the critical window.
The idea, based on reanalysis and other studies, is that HT might offer some cardiovascular protection, but potentially only if it started early in menopause, closer to the time period stop, maybe before significant atherosclerosis has developed. The women in the main WHI trials were generally started much later than that window.
So timing is potentially crucial. Given all that, what's the bottom line now? What are the current recommendations on using HT?
They're much more cautious. The guidance now is clear. HT should not be used for the primary or secondary prevention of heart disease. Its main role is for managing moderate to severe menopausal symptoms, like those disruptive hot flashes that are really impacting quality of life.
And even then,
Even then, the mantra is, use the lowest effective dose for the shortest duration possible, always after discussing the individual woman's risks and benefits. And non-hormonal options, like certain SSRIs for hot flashes or vaginal moisturizers, should definitely be part of the conversation.
okay, that makes sense. A much more tailored and cautious approach. Let's quickly touch on the breasts before we wrap up. Functionally tied into this whole system.
Right. Specialized glands, supported by Cooper ligaments, divided into lobes with alveoli, where milk is made. And their development perfectly illustrates the distinct roles of estrogen and progesterone.
How so?
Estrogen primarily drives the growth of the ductile system. Think of it as building the plumbing, the milk ducts. Progesterone, especially during the luteal phase in pregnancy, stimulates the growth of the alveolar secretory tissue, building the little milk factories themselves.
And during pregnancy, both hormones surge, leading to that feeling of fullness and preparing for lactation. But making and releasing milk involves two other pituitary hormones, doesn't it?
Yes, milk secretion, the actual production by those alveolar cells, is mainly controlled by prolactin from the anterior pituitary. But milk ejection, the letdown reflex that releases the milk, is triggered by oxytocin from the posterior pituitary, usually stimulated by the baby suckling.
Yeah.
Two different hormones, two different jobs.
A really elegant coordination. Okay, that brings us through the whole system structure, the HPO axis control, the cycle, menopause, HT controversies, and the breasts.
Yeah, and if there's one core takeaway for you listening, it's that this whole system hinges on that precise hormonal hierarchy: hypothalamus, pituitary, ovaries. So much of the pathophysiology, whether it's cycle disruption, menopausal symptoms, or even the risks tied to HT, really comes down to shifts or imbalances in that hormonal signaling.
And maybe a final thought to leave you with. Think about that connection between critical body fat and maintaining the menstrual cycle. It really drives home that reproduction isn't just this isolated system. It's deeply interwoven with the body's overall metabolic health and energy balance. That's a theme you see again and again in pathophysiology, the interconnectedness of it all.
Well said. Thank you for tuning in for this deep dive into the female reproductive system's foundations.
We really hope this structured walkthrough helps those core concepts stick. Thanks for joining us, and we'll catch you on the next deep dive.